Hi, and welcome to the Intermediate STEM Academy's second engineering challenge for this school year. If you haven't attended any of the Intermediate STEM Academy sessions, this is a great time to get started. You'll need some common household items such as rubber bands, paper clips. If you have bubble wrap, that would be great. Cotton balls, binder clips, some tape, and a few more items. Now, as far as measuring tools are concerned, if you have a digital scale, that would be great, but you don't need it. You need some sort of a measuring object, such as a ruler or measuring tape, a stopwatch, and just general household items. Paper bags, aluminum foil. You'll need a balloon for the next challenge. Cardstock, cardboard, plastic cups, pipe cleaners, pennies, and so many more. NASA's lunar exploration missions will collect scientific data to help scientists and engineers better understand the moon's features and environment. These missions will ultimately help NASA determine the best locations for future human exploration and lunar bases. Your challenge will be to design and build a satellite that meets specific size and mass constraints. The information gathered by lunar exploration missions will add to information collected during earlier missions. Some of these missions gathered data that caused scientists to have more questions they hope to solve with new instruments on new satellites. So, for example, you may remember from our first guest speaker, NASA has recently sent a satellite to look for water ice on the moon. Thus, the satellite carried instruments, sometimes called detectors or sensors, to look for the ice. Other instruments will help to collect data to make exact maps of the moon's surface and make careful measurements of the radiation falling on the lunar surface. So your challenge or your mission is to build a model of a lunar exploration satellite with general building supplies. You can use various shaped beads or buttons or paper clips or cotton balls or any of the materials that we have attached to this list. Your task is going to be to use the data on the Ask, Imagine, and Plan worksheets provided, calculate the total mass of the instruments. The total mass, including detectors, probes, sensors, and solar cells, can be no greater than 10 grams. The entire satellite must fit within, we're going to say, I think, an oatmeal canister. Finally, the satellite must withstand a 1-meter drop test without any pieces falling off. The object is to design your own satellite. These are the instruments you may choose to put on your satellite. So a camera has a total mass of 2.5 grams. A gravity probe has a total mass of 2 grams. A heat sensor has a total mass of 1 gram. Here's the tricky part. Each of these instruments requires a certain number of solar cells to operate your satellite. A solar cell collects energy from the sun to power these instruments. Each solar cell has a mass of 5/10 of a gram. A camera requires 3 solar cells. A gravity probe requires 2 solar cells, and a heat sensor requires 1 solar cell. So you need to factor that in when you are planning your satellite that weighs less than 10 grams. Okay? Now here's some questions that you'll see that are going to give you kind of a good sense of how to figure out the weight of all of the pieces that you're going to need for your satellite. You're going to answer these 2 questions, and then you're going to draw your own satellite. You're going to plan your satellite by drawing it on this piece of paper. Next, you're going to create a hypothesis. So when our team, meaning you, or if you're doing it with any family members or friends, when you drop your satellite from the height of 1 meter, what's going to happen? What's it going to do? Then you're going to record your observations. Describe what happened. Did any of the instruments fall off? Was the satellite damaged in any way? And then you're going to share. Create a blog. Take some pictures. We have a wiki in our Intermediate STEM Academy organization on Blackboard where you can share any pictures or videos or possibly blogs that you may have. Here's an example of a student blog from last year. And you can see she included information such as the weight, what materials she used, and did it withstand the 1 meter drop test. So a review of the engineering design process. Start with a question, and your question is going to be, how can you create a satellite with certain materials that fall within a certain weight to withstand a 1 meter drop test, which would simulate a satellite perhaps landing on the moon? You need to imagine a possible solution and then plan your satellite. Make sure when you plan your satellite, you are drawing a picture. You are looking at the sheet that's attached that shows the measurements, and you're going to keep your satellite under that 10-gram maximum weight. And eventually you're going to get to create, experiment, and improve your design. But for right now, we're going to stop at plan. Because on Monday, February 3rd, we are holding an intermediate STEM planning session at 1 p.m. in Collaborate. So bring your ideas, bring your plans, bring your materials, and enjoy the intermediate STEM program. We hope to see you there at 1 p.m. on February 3rd.